Everyone, I'm Dr. T.S. We are going to discuss on the topic rate of the reaction. So the rate of a reaction can be defined as the change in concentration of any reactant or product in unit time. So the rate of reaction can be written as a change in concentration of any one of the reactant. Suppose in a reaction there are more than one reactant will be there. We can use only one reactant to define the rate of the reaction. Unit of the rate is concentration by time because we are taking the concentration in the numerator and time in the denominator. So that time may be second or it may be minutes or it may be hours. If you see the progress of the reaction, once the reaction has started, the concentration of the reactant is more and the amount of the product is very less. Once, once the progress is going on, the concentration of the reactant is keep on decreasing and the concentration of the product is keep on increasing. Okay, so you can see that easily we can understood by seeing this graph. You can see that red line indicates the increase in concentration with respect to time and the blue line indicates the decrease in concentration with respect to time. So we can use either reactant or product to define the rate of the reaction. So rate of the reaction is directly proportional to concentration of the reactant in general and it can be mathematically represented as minus dA by dt. That is a change in concentration of the reactant with a small interval of time. This we can also write in terms of the product. There we have to use a positive sign which indicates that the concentration of the product is keep on increasing. So the rate law, which is the rate is directly proportional to the product of the concentration of the reactant and each concentration term is raised to the power equal to the number of moles actually participating in the reaction. For example, a reaction which involves A and B are the reactant of A moles and B moles, which will give you the product C and D of mole C and D. According to rate law is directly proportional to concentration of the reactant A to the power A and B to the power B. The proportionality symbol is removed by rate constant K. Okay, so the powers of A and B are determined experimentally, which will nothing but order of the reaction, and K is the rate constant for the given reaction at the given temperature. So the rate constant is appears in the rate law, but it is independent of concentration, but depends upon the temperature and the nature of the reaction. It is equal to the rate of the reaction when the molar concentration of the reactant is at a unity. So now we can see the difference between rate of the reaction and rate constant of the reaction. Rate of the reaction is it represents the speed at which the reactants are converted into products at any instant of time. It is a rate constant is only a proportionality constant. And rate of the reaction is measured as the decrease in concentration of the reactant or increase in concentration of the product. But rate constant is equal to the rate of the reaction when the concentration of each of the reactant is unity. It depends upon the initial concentration of the reactant, but rate constant does not depend on the initial concentration of the reactants. Now we can see order of the reaction. What is the order of the reaction? Which is can be defined as the sum of the powers of the concentration of reactants in the rate law expression. You can see here A and B giving rise to the product and the rate equation K into A power X and B power Y. The order of the reaction is nothing but sum of the powers of the concentration terms, that is A and B X plus Y. So these are types of order of reaction. It is a zero order reaction. So in if it is a zero order reaction, rate is equal to rate constant. Usually photochemical reactions follow the zero order kinetics. First order reaction, the rate is directly proportional to the concentration of the reactants, and second order reaction depends upon the square of the concentration term. If it is a two different reactor, A and B means A and B powers are saponification of ester is the best example. And a fractional order reaction, the order is a fraction. It may be 1.2, 1.5, 1.3, any number it can be. The very good example is a decomposition of acetaldehyde, and there is a mixed order of the reaction is also possible. So, in general, we can say that some of the powers of the concentration terms, and it is determined only experimentally. It can be zero, fractional, or whole number. Then, molecularity. There is nothing but total number of reactants taking part in an elementary chemical reaction is called as a molecularity. Here, number of species colliding in a elementary step, it is always being a whole number and it cannot be zero or fractional. So if one molecule is involved, it is called unimolecular. Two molecules means a bimolecular. Three molecules means a termolecular. Order versus molecularity. It is a order is a theoretical concept. Molecularity is a determined experimentally.